Now I want to turn our attention to example number 4. And this is a question I actually want you to try on your own. It's got 3 parts and they're all very unrelated. But I'd ask you to pause the video right now to try to see if you can practice working through these questions to see if you can understand how they're done. For part A, I would suggest that you start by making a table of values. For part B, you can compare back to something that we did on example 1B. And for part C, you might have to think a little bit creatively about how to answer the question there. But pause the video and then hit unpause to see me work through the solutions. For part A, I could start by noticing the following when I set up a nice table of values. So let's see, I want to have values here for t, x, and y. So if I plugged in something like a value of 0, I could see that my x turns into 1, my y turns into 1. At a value like a pi over 2, I'm going to get 0 and 0. At a value of pi, I'm going to get negative 1 and positive 1. At 3 pi over 2, I'm back to 0 and 0. And at 2 pi, I'm going to have the values of 1 and 1. So if I was to go ahead and attempt to try to sketch out a picture of what this might look like, I'm going to end up with, let's see, a point at 1, 1, a point at 0, 0, and a point at negative 1, 1. Now, I can start to see maybe how these things might connect, and maybe get an idea that, well, I'm either going to have some sort of like curve that connects these, or maybe a rigid V shape. But I can definitely see something interesting. At t0, I'm at this top right point. Then I go down to the origin, then I go over to the left, and then I kind of seem to reverse course. And what I'll notice is that if I was to continue values of t past 2 pi, I would actually tend to just continue to repeat this pattern. Now to figure out how to connect the dots, I could either plot more points, or notice the following relationship that exists between the variables. Notice here that if x is going to be the same as a cosine of t, and y is just a cosine of t, all being squared, then it's really the case that y is equal to x squared, just with a restriction. The values of x can only go from negative 1 to positive 1. So what I actually have here in the picture is a nice parabola. It's limited. It can only go on this restricted range. Now, when I go ahead and I deal with the direction here, the direction again is kind of tricky, because while I move down this way and then up this way, if I graph for too long, I actually have to turn around and kind of double back. And so eventually these arrows are going to get so confusing that they won't be very meaningful. This is, however, very important. We'll see more examples like this in the future. If I was to take a look down here at part B, I want to find parametric equations for the curve determined by this equation. Well, again, something easy that I might be able to do here to split this apart into 2 curves is to say, well, what if y was just equal to the value of t? Then I could completely rewrite the x formula as t to the 4th minus 3t squared. Now that's not the only option. I could really select y to be almost anything in the universe that I want. Notice if I selected y as t plus 2, which is totally fine to do, then my value up here would just be t plus 2 to the 4th minus 3t plus 2 squared. And this is also perfectly acceptable. For part C, I want to find parametric equations which describe the motion of a particle that traverses a circle of radius 4 one time in a counterclockwise direction. So if I was going to go ahead and make a picture of this, I maybe have something like the following. I want to go ahead and I want to traverse this circle counterclockwise. So I want to move around it like this, and I want to do that one time. Well, one thing that I might be able to think about is that if I want to rotate in a complete circle, my values of t could actually be thought of as angles, maybe rotating from something like 0 to 2 pi. But then what would I choose for my formulas for x and y? I could think about some sort of function that I could use that could maybe at least start to help me graph these points over here. Well, for my x value, I might have been able to choose something like a cosine of t, because notice that when I plug in 0, I get a 0, or I get a 1, sorry, for an x coordinate, and then I could imagine plugging in something like a pi over 2 and getting an x coordinate of 0 and slowly moving around. For my y coordinate, I could do something like the sine of t, and you could double check that if you were to type this into the calculator, it does indeed graph a circle oriented or being traversed in a counterclockwise direction.